The strong nuclear force. Here we've got a nucleus. How can a nucleus contain lots of positively charged protons when like charges are supposed to repel? Well, they are repelling each other, but there's also a much stronger but shorter range force called the strong force. And this acts between all nucleons, which is all protons and neutrons. The electrostatic repulsion, of course, only acts between the protons. I'm going to plot a graph here of the two forces. So this is the separation of the protons. As the protons get further away, we'll look at what happens to the force. A positive force in this direction is a repulsion. They're pushing each other apart. A negative force in this direction, an attraction. They're pulling each other together. First, the electrostatic force, which is proportional to 1 over r squared. It follows an inverse square law. The electrostatic force has infinite range, although it does of course get weaker with greater separation. So the electrostatic force will have a shape something like this. The electrostatic force is sometimes called the Coulomb force. Now the strong nuclear force has a range of just 3 to 4 femtometers, femto meaning 10 to the minus 15, so it is a very short range force, and it has a shape something like this. So at very short distances it is a repulsive force. It stops the nucleons squashing each other. But then it becomes a very strong attractive force, but quickly falls away again to 0 at around 3 to 4 femtometers. Important is the sum of the two forces, and if we do the sum of the two forces we get a shape something like this. All I've done is added the two forces together. So for instance at this point the electrostatic force has roughly the same repulsion as the strong force has attraction. So at this point the two forces cancel out. So that means at this point, which is around about 10 to the minus 15 meters, the two protons at this separation will be in equilibrium. So this will give us the separation of two protons within the nucleus. Now neutrons, being nucleons, will provide strong force, but as they're neutral they do not experience electrostatic repulsion. That is why larger nuclei tend to have more neutrons than protons. This enables them to be stable.